Hello everyone and welcome to this lesson. In this video we will explain and have a practice on writing down the chemical equations, and also we will revise writing down chemical formulas for ionic and covalent compounds whenever we have a chance to do this. And also we will practice together here balancing chemical equations. Okay, so this is a very important skill in chemistry. The student should be able to write down a chemical equation and also to balance them. Let's get started now. Solid sodium metal reacts with liquid water to produce aqueous sodium hydroxide and hydrogen gas. So the question now is telling you a situation or telling you a chemical reaction. Okay, so for each of the following reactions we should write down the balancing chemical equation and include the correct state of matter for each substance which is given in the question. The first question here, solid sodium metal reacts with liquid water. So a solid sodium metal, this is Na, solid. So here I'm just specifying the state of matter because it is mentioned in the question. Solid sodium metal reacts with means plus liquid water. So water has the symbol of H2O, which is L, and to produce aqueous sodium hydroxide. Sodium hydroxide, let's revise. This is an ionic compound, guys. And an ionic compound, before writing down the chemical formula in the equation, you should do it on a side. Okay, so you put the charges. Sodium belongs to the first group in the periodic table, so it has a charge of +1, and the hydroxide group, this is a polyatomic ion which has a charge of -1. So since they have the same charges but opposite, they cancel each other. So the result here is this sodium hydroxide has this chemical formula. This is the first product. And hydrogen gas H2, and here guys focus that hydrogen, this is the symbol of hydrogen, but why do we write 2? Because hydrogen gas exists naturally as diatomic molecule. As we said before, hydrogen gas, all gases exist naturally as diatomic molecules. Okay, so let's include the state of matter. Sodium hydroxide is aqueous, AQ, we put AQ, which means dissolved in water, and hydrogen is a gas. Okay, after writing down the chemical formulas and putting the reactant side and product side in a chemical equation, the last step is to balance the equation. What is meant by balancing chemical equation? Balancing chemical equation means that the number of atoms in the reactant side should be the same and equals the number of atoms on the right side, which is the product side. Okay, so let's do it one atom by atom. So this is sodium here, one sodium atom here and one sodium atom, so it doesn't need any balance. Hydrogen H2, and here it is 2. But here guys, you should be aware that the hydrogen here one atom and here 2 atoms. So this is one of the things that many students actually make mistakes in this part, because they just count the hydrogen here. No, also count this hydrogen, because we count all atoms of hydrogen in this side. So actually we have 3 hydrogen atoms in this side and 2 hydrogen atoms in this side. So what we should do right now is to balance this by making, this is an even number and this side has odd number. So if you have this situation, just change this odd number into an even number, which means if I add a coefficient of 2 here, now the number of hydrogen becomes 4. 2 hydrogens here plus 2 hydrogens here, so we have 4 hydrogen atoms on this side, and hydrogen here is 2, so I'm going to add a coefficient of 2. So now it is a balancing chemical equation. Okay, because I told you before balancing it was 2 and here 3 hydrogen atoms, but now after adding the coefficient it is balanced. the hydrogen balance, because now here we have 4 hydrogen atoms and here we have 2 plus 2, so there are 4 hydrogen atoms. It is balanced, but we still have a missing atom which is not balanced, which is a sodium atom. Since we added the coefficient of 2 to balance the hydrogen, okay, the sodium has been raised from 1 atom to 2, because 2 also is multiplied to 1 sodium atom. So simply I should add a coefficient of 2 here to the sodium atom, and now the equation is balanced. Let's check for the oxygen. Now you have here 2 oxygen atoms and here 2 oxygen atoms. Now every atom is happy because the numbers on the left side equals the numbers on the right side. And don't panic, okay guys, because by doing more examples it's going to be very easy for you. Aqueous hydrochloric acid HCl reacts. So if any acid, this is the acid HCl, okay, it's given information in the question. Hydrochloric, it's called hydrochloric acid, and it is aqueous. Aqueous means it is dissolved in water. Reacts with solid calcium carbonate. So I'm gonna work the calcium carbonate here on the right side at the beginning, then I write it down in the chemical equation as I told you. So this is an ionic compound. In any ionic compound you should start with the charges, so you can write down the final chemical formula in a correct way. So calcium actually belongs to the second group of the periodic table, and also it always loses 2 electrons. It has a charge of 2 positive. And carbonate, one of the polyatomic ions, which has a charge of 2 negative. And obviously you can see that the charges are equal but opposite, so they cancel each other. So the final formula of calcium carbonate is actually CaCO3. This produces, and calcium carbonate is solid in the solid state. This produces aqueous calcium chloride. So I'm gonna again work out the calcium chloride on the right side here. Calcium again belongs to the second group of the periodic table. It has a charge of 2 positive. Cl belongs to the 7th group in the periodic table. It has a charge of -1. So since the charges are not equal, what should we do? Yes, correct. We crisscross the numbers, right? Again, in order to cancel out the charges whenever they are not equal, just crisscross the numbers, okay? So the final formula, or the correct formula of calcium chloride, is CaCl2, okay? And this is an aqueous solution, okay? And liquid water H2O, which is liquid, it's written in the question, and carbon dioxide gas, CO2, okay? After writing the formula of each compound, or each component, or each species in the chemical reaction as reactant or product, now let's balance them, okay? So let's check for the hydrogen atoms on this side. It has only one, the left side has 1 hydrogen atom, and here it has 2. So the first step, I'm going to add a coefficient of 2 here to balance the hydrogen on both sides, and now it is okay. And now let's check for the chlorine. How many chlorine atoms do we have here? It is 2. It's not 1, guys. I don't say it 1 because the coefficient of 2 is multiplied to 1 chlorine atom, so it is 2. The number of chlorine here is 2, and here the number of chlorine atoms are 2, so it is balanced. How many calcium atoms? 1, and here is 1. The carbon is just 1, and the oxygens are 3. 3 oxygens also exist here. So now just adding 1 coefficient before the hydrochloric acid makes this equation to be balanced, okay? Question 3, solid iron 3 oxide. Iron, one of the transition metals, and whenever you have a transition metal with different oxidation states, the question will always give you the oxidation number of iron in this compound, which means iron oxide is an ionic compound because it has metal, right? And iron 3 means Fe The iron 3 positive. 3 means 3 positive. This is the charge of the iron. It is given in the question, okay? Because we don't know it. Oxygen belongs to this the sixth group of the periodic table and has 2 negative charge. As again, we have this kind of ions forming one compound. In order to cancel out the charges, just crisscross the numbers. So the final formula, the correct formula for iron oxide, iron 3 oxide is Fe2O3. Okay, this iron oxide, and this is solid. This is a solid state. Plus reacts with carbon monoxide. This is a covalent compound, guys. I do remember that when we said carbon monoxide means this compound is actually formed out of 1 carbon atom and 1 oxygen atom, okay, and this is a gas to produce solid iron and carbon dioxide gas, CO2, okay. Carbon dioxide, these are the products. So iron solid is a product and carbon dioxide gas is a product. Now, after writing down the chemical formulas in a correct way, now let's do the balance, okay? The iron atoms on the left side are 2 and on the right side just 1. So I'm gonna add 2 as a coefficient to just raise the number of iron atoms on the right side to 2 to equal the number of iron atoms on the left side to be as it is 2, okay? Now let's balance the carbon. Here we have 1 carbon, the oxygen. How many oxygen atoms do we have here? We have 4 oxygen atoms, and here we have just only 2 oxygen atoms. So in order to make it 4, I'm going to add 2 here as a coefficient. This is the regular steps that we should do, like you go atom by atom to and compare it to the other side so you can balance it, okay? So when we get to the oxygen, okay, when we reached here, oxygen actually in this side are 4 oxygen atoms, and in here it was just 2. I just added 2 balance the oxygen. But now there is a problem here, guys, because the carbon is 2 atoms. Actually, the carbon are 2 atoms now, but multiplying the coefficient of 2 by 1, so it means 2 carbon atoms exist in this side of the equation. So what should we do now? What should we do now is to put a coefficient of 2 here, but this will imbalance the oxygen atoms, right? Now we messed up the oxygen atoms by adding this 2. So there's a problem here. The problem here that I should put the same coefficient, okay, the same coefficient for carbon and oxygen, and it has to be the same, okay? So in this case, I advise you guys, you can do it by your mathematical skills easily, but if you feel like you're messed up here or you can't do it, just raise the number, which means if I just add 2, because 2 here, you know what's the problem? That oxygen is 3 and oxygen here is 2, so the number of oxygen atoms are 5 now, while the number of oxygen here are just only 4. That's a problem, okay? So in order to solve this problem, we can change the coefficient, okay? Just raise it up 1. Why I'm doing this? Because I know that since carbon and oxygen are in the same compound here, and carbon and oxygen in the same compound here, so they should have the same coefficient, and that coefficient will balance both carbon and oxygen, okay? So if 2 as a coefficient doesn't work for both, let's try a coefficient of 3. You know what I mean? Because I know that the coefficient of both will, it has to be the same, and it will balance both of them. So let's try 3 as a coefficient. So I just raised 2 to 3. I will try using 3 instead of 2. So let's check now. How many carbon atoms? 3 carbon atoms, 3 carbon atoms. How many oxygen atoms in this side? Actually, there are 6 atoms of oxygen, because O3 plus 3O, here 3 oxygens plus 3 oxygen, so the total is 6 oxygen atoms in this side, and in this side 3 multiplies to 6 oxygen atoms, so the atoms of oxygen now is balanced. Okay guys, so each one is happy now. Iron is balanced to oxygen, as I said, 6 atoms in this side and 6 atoms in this side, so it is balanced. Carbon 3 atoms and carbon are 3 atoms, so it is balanced. Okay, so guys, here don't panic, because don't feel it hard to do it, because I'm always saying this: balancing chemical equation is a skill. Okay, you can do it by any way that you want, but the final objective, the final mission that you should accomplish is to make the number of atoms on the left side equal the number of atoms on the right side. Okay, that is the objective. Next question: aqueous silver nitrate reacts with aqueous sodium chloride to produce solid silver chloride and aqueous sodium nitrate. All of the 4 are ionic compound. Let's do it here on the right. Aqueous silver nitrate. Silver has the symbol Ag. Ag, you should be aware that the silver is always having a charge of +1. Okay, silver belongs to the transition metals, but it doesn't have multiple charges. It doesn't have different oxidation states. The silver is always having an oxidation number of +1 in any chemical reaction. Okay, memorize this. Nitrate, one of the polyatomic ions, which is NO3, and that has a charge of 1 negative. Okay, so since the charges are the same, we cancel them out. So the correct formula for silver nitrate is AgNO3 plus. Aqueous sodium chloride. Sodium chloride Na positive, Cl negative. First group, 7th group, they cancel each other, so this is NaCl, produces solid silver chloride. So now the silver with chlorine will make one compound, +1, -1, so they will cancel each other. So this is AgCl plus, it said aqueous solid sodium nitrate, so sodium with the nitrate will make one. So this is, guys, called a double displacement reaction. Okay, because silver nitrate and sodium chloride, different compounds, and they form, everyone will take the opposite one. They just a change on displacing the ions together. So silver chloride and aqueous sodium nitrate. Sodium nitrate has this NaNO3, as they have the same number of charges but different. This is +1, this is -1. Okay, and it's a balanced equation. It doesn't need any kind of interfering here, okay, to balance them. Let's put down the state of matter here. So silver nitrate is aqueous solution, sodium chloride is aqueous, silver chloride is not aqueous. Silver chloride, guys, doesn't dissolve in water. This is one of the ionic compound that doesn't dissolve in water, silver chloride, and it's written here it is solid. Because, so why solid? Because it doesn't dissolve in water, and aqueous sodium nitrate exists. Solid magnesium metal burns in oxygen gas to produce solid magnesium oxide. So magnesium metal, Mg, solid, burns in oxygen, means reacts with oxygen gas. Oxygen O2, you should put it 2. Why? Because, as we said before, any gas actually is a diatomic molecule. Oxygen gas to produce solid magnesium oxide, MgO. How do I know this? Because magnesium belongs to the second group of the periodic table. It has a charge of +2, and oxygen belongs to the sixth group in the periodic table. It has a charge of -2. They cancel each other, so this is solid. It forms this compound, magnesium oxide. In order to balance, first of all, I see that the oxygen here is 2, the oxygen here is 1, so I'm going to add a coefficient of 2, and this is 2 MgO. Now, adding this coefficient raised the magnesium atoms in this side to be 2, and in this side just only 1, so I'm going to add 2 to this part. Now, it is a balanced chemical equation of the reaction of magnesium and oxygen to produce magnesium oxide. Aqueous sulfuric acid, so it's a given information here, the sulfuric acid formula, and it is aqueous, dissolved in water, H2SO4, plus reacts with potassium hydroxide. We just said before that potassium belongs to the first group of the periodic table. I just said in a previous example that hydroxide is a polyatomic ion and has a charge of 1 negative, so they cancel each other. So this is a potassium hydroxide, which is aqueous. Okay, to produce aqueous potassium sulfate, potassium has a charge of positive 1, and the sulfate SO4, this is a polyatomic ion, has a charge of 2 negative. Okay, and because they don't have the same charge, so we cancel out the charges by crisscross the numbers. Okay, because they don't have the same number of charges, so the correct formula of potassium phosphate is sulfate, sorry, is K2SO4 plus water, H2O. Okay, this guy's a reaction called neutralization. Neutralization, because whenever an acid reacts with a base, it produces salt and water. Okay, so potassium sulfate is an aqueous solution dissolved in water, and water definitely is a liquid. Let's balance this equation. H2 SO4 SO4. I balance SO4 as a whole, okay, as an atom. Here K is 1 and K is 2, so I'm going to add 2 as a coefficient here. Why? Because K is 1, K is 2, right, in the other side. So I'm going to add a coefficient of 2 here. So 2 here. So how many hydrogen atoms do we have now? We have now H2 and 2H. We have 4 hydrogen atoms. It was 3, by the way. I didn't count this in the previous. Okay, so now it's 4 now. 2 and 2, it's 4. So immediately I'm going to add a coefficient of 2 here to balance the hydrogen. And now oxygen also is balanced, 2 and 2. Okay, guys, everyone is happy now. Okay, the hydrogens on both sides are 4. Okay, 4 hydrogen. Okay, the sulfate group is just 1. The sulfate group is just 1. Okay, the oxygen atoms, here we have 2 oxygen atoms, and the other side 2 oxygen atoms. Everyone is happy now. Okay. Solid copper 2 carbonate. Again, copper is one of the transition metals, so the charge is written here, so we will be able to write down the chemical formula. So copper 2 positive and carbonate CO3 2 negative, since they have the same number of charges but different, so they cancel each other. So copper carbonate CO3 decomposes. Decompose means this is a decomposition reaction. Decomposes means it breaks down into its components by heating. We put a triangle here on the arrow, so you refer that, or you mentioned that this is a heating process, or this is actually this reaction is called thermal decomposition. Thermal decomposition means this is this compound breaks down using heat. Produces solid copper 2 oxide, copper 2 oxide 2 negative, so they cancel each other, so CuO. Okay, this is the copper 2 oxide, and carbon dioxide gas is equivalent, no charges, so CO2. Now let's write down the state of matter. So solid copper to carbonate, decomposable, produces the solid copper oxide and the carbon dioxide gas. Okay, and this equation again is balanced without adding any coefficients. Copper 1, C1, C1, the carbon, and oxygen 3 oxygens. Okay. Nitrogen gas reacts with hydrogen gas to produce ammonia gas. And you know this reaction, guys, is called Haber process. This is the Haber reaction. Okay, when nitrogen reacts, nitrogen N2, which is gas, reacts with hydrogen gas to produce ammonia gas, ammonia NH3. Okay, don't forget that. Okay, ammonia gas is one of the very important gases in industry. Okay, gas. Let's write down, let's say balance the equation N2, so I have to add a coefficient of 2 here to N, and let's balance the hydrogen atoms. How many hydrogen atoms here? 2 hydrogen atoms. How many hydrogen atoms here? 2 multiplied 3 multiplies 3, 6 hydrogen atoms. So in order to balance this, divide 6 by 2, so you have to add a 3 of coefficient here. Now everyone is happy. Solid zinc metal, so zinc metal, which is solid, reacts with aqueous copper 2 sulfate, the copper 2 positive, sulfate is O4 to negative. This is one of the polyatomic ions since they have the same charge, so copper sulfate. Okay, copper 2 sulfate, this is an aqueous solution, produces zinc sulfate. This zinc, guys, you can see it, the zinc sulfate, the question didn't mention the oxidation state of zinc. Why? Because zinc is always having a charge of 2 positive. Memorize this. So we said before, silver Ag has a charge of positive 1, zinc has a charge of positive 2. Always, it doesn't have any other charge in any chemical reaction. So zinc, it's a 2 positive, and sulfate is 2 negative. So the sulfate is 2 negative. Okay, so they cancel each other. So in this case, it's zinc sulfate plus copper. Okay, guys, this is actually an aqueous solution of zinc sulfate, and the copper is solid. Okay, what happens in this reaction? In this reaction, the zinc displaces the copper atom, okay, and forming zinc sulfate and pushing the copper away, right? This is, guys, called a single displacement reaction. Okay, single. Zinc is much more stronger, much more reactive in the chemical reaction, and it takes the place of the copper to produce zinc sulfate and copper solid. And it is a balancing chemical equation, doesn't need any kind of balancing. Okay, methane gas, okay, CH4 is given information. Combust means burns in oxygen, which means it reacts with oxygen gas, O2, don't forget that. Okay, combusts in oxygen, burns with oxygen, reacts with oxygen. So you should put it down this way. So the methane gas, oxygen gas, burns in oxygen to produce carbon dioxide gas and definitely water. Why? Because this is called combustion reaction. Okay, guys, this is called combustion reaction. Okay, in the combustion reaction, and water finally evaporates because of the heat. So this is called this is burning reaction. Okay, in a burning reaction, the oxygen is always burns the hydrocarbon, any kind of hydrocarbon, to produce carbon dioxide and water. The products are always the same in any combustion of hydrocarbon. Now let's write down the let's balance. Here 1 carbon atom, on the other side 1 carbon atom. Hydrogens are 4 here, right? So on the other side there are 2, so I'm going to add a coefficient of 2 here, so there are 4 hydrogen atoms. And now oxygen is also balanced. Oxygen not balanced because 2 oxygen and 2 oxygen, there are 4 oxygen atoms, so I need to add a coefficient of 2 here, by which we balance the oxygen atoms. Okay guys, don't forget oxygen 2 here and 2 here, 4 oxygen atoms. And on the other side it was 2, but I raised it up to 4 by adding a coefficient of 2. Okay, now it's a balanced chemical equation. Now let's practice the balancing chemical equations. Okay, the first question here, iron in this side is 2, okay, and on this let's compare. I did it immediately. Iron is 1, iron is 2, so add a coefficient of 2 here. Next step, oxygen is 2, oxygen is 3. Now you have even number, odd number, just raised both to the first common factor, okay, so which is 6, right? So I'm going to multiply 2 by 3 and 3 by 2, so both would be raised up to 6 atoms of oxygen. But now the iron, because I add a coefficient of 2 instead of being 2 atoms only of iron, now there are 4 atoms of iron here in this side of the equation, so I have to raise this number to 4. Okay, so guys, my advice in any exam or any in any test, in balancing chemical equation, if you have a question, okay, you always use a pencil. This is my advice. Use a pencil at the beginning. Why? Because you could have erased you could erase any of the coefficients that you write down in the equation in order to balance. Okay, and this is correct. You can erase it, you can change the numbers, okay, because the final objective is to make it balanced. Okay, H2O2, the hydrogen gas reacts with oxygen gas to produce a water. Okay, I want to also enforce the types of chemical reaction in this part. So let's write down the type of chemical reaction in each of these examples. So when iron reacts with oxygen, produces iron oxide. Two components, 2 species react together to form one component or one species. This is called a synthesis reaction or combination reaction. Synthesis reaction. Okay, I'm going to reinforce the types of chemical reactions in this part. The second one, what hydrogen oxygen reacts together to form water. This is also again is a synthesis reaction. Okay, why it's a synthesis reaction? How do I know? Because 2 species form 1 species. Okay, which means 2 reactants form 1 product. This is a synthesis. This is a combination of hydrogen and oxygen to form water. Okay, so the oxygen here is 2 and here is 1, so I'm going to add 2 here in order to balance the oxygen. Okay, here is 2, here is 2. Okay, and the hydrogen atoms now, they are 4, so I'm going to add a 2 as a coefficient here. When it is multiplied to 2 hydrogens, it is 4, and definitely the oxygen here has a coefficient of 1, but in the ordinary chemical equation we don't write 1, but here, because this is a question of balancing, I just wrote it down. Aluminium reacts with hydrochloric acid to form aluminum chloride and hydrogen gas. This is a single displacement reaction. I'm going to write it down and explain it. So the Cl here is 3, the Cl here is 1, so I'm going to add a coefficient of 3 here. That's the first step. Then the hydrogen, 3 hydrogen atoms, and here is 2. As I told you before, whenever you have odd number and even number raise both of them to the first common factor, which is 6 in this case. So I'm going to multiply here by 2 and multiply there by 3. So if you multiply 3 by 2, it will be 6, right? And I will multiply here by 3, it's gonna be 6. Okay. Why did I do this? Because when you multiply, because I wanted to balance the chlorine atom, the hydrogen atom. Okay, 6 hydrogen atoms, 6 hydrogen atoms. Okay, but now the chlorine atom, the number of chlorine atom raised to 6 now. 6 multiplies 1 is 6, and here is 3. So easily I'm going to add a 2 as a coefficient here. This coefficient I just added to be multiplied by 3Cl to raise it to 6 atoms. So now the Cl is happy because it is balanced on both sides. But the chlorine, the aluminum atom also is raised to 2. So I need to add 2 here so everybody is happy. Okay, and this is, guys, called single displacement reaction. Why? I explained before, single because the aluminum is very strong. It takes the place of the hydrogen and form an ionic compound with the chloride ions to form aluminum chloride and pushing the hydrogen gas away from the reaction. This is single displacement reaction. Okay. This is a single displacement reaction. Methane reacts with oxygen to form carbon dioxide and water. Okay, this is also a combustion reaction. This is a combustion reaction. This is a burning reaction. Okay, producing So this is a combustion reaction. Combustion means burning. I told you before, oxygen burns the methane to produce carbon dioxide and water. In order to balance the oxygen, I'm gonna put 2 here and 2 here, okay? And the hydrogen 4, here is 4. Oxygen here is 4, and 2 plus 2 equals 4. So now it is easy. This is an easy question of balancing. Okay, guys, we did that before. The ammonia and ammonia reacts with hydrogen to produce ammonia, and nitrogen reacts with hydrogen to produce ammonia. So I'm going to put 2 here as a coefficient. As the number of N is 2, I'm going to add a coefficient of 2, and now the hydrogen atoms become 6 atoms of hydrogen. So I'm going to add 3 here. This is a synthesis reaction. Okay. KCl, potassium chlorate, decomposes to produce potassium chloride and oxygen gas. Okay, guys. So first of all, I'm going to balance the oxygen atoms, as we have an odd number here and even number here. So we'll do the opposite. Like I'm going to add 2 here and 3 here. Okay, so now 6 oxygen atoms exist in this side and 6 oxygen atoms exist in this side. Okay, and 2 KCl, so I'm going to add a 2 here. Now everybody's happy, and this is a decomposition reaction. What is meant by decomposition? Decomposition reaction, this is a breaking down reaction. Okay, this is another example of combustion reaction, guys. I just told you that oxygen, when it reacts with any hydrocarbon, the results the product will always be carbon dioxide gas and water. This is called combustion reaction. Okay. We have 2 carbon atoms here and 1 carbon atom here, so I'm gonna add 2. I'm doing this to balance the carbon atom. Hydrogen is 6, and the hydrogen here is 2, so I'm going to add a coefficient of 3. So now 3 multiplies 2 is 6, and we have 6 here. Oxygen, we have 2 oxygen atoms here, and how many oxygen atoms do we have here? 4 plus 3, we have 7 oxygen atoms. So in order to do this, okay, what is the number if you multiply by 2 gives you 7? So divide 7 by 2, you will know this number. 7 divided by 2, it is 3.5, okay? The equation now is balanced, okay, but this is not the final step. The final step, I'm going to multiply the whole equation by 2. Why I'm doing this? To get rid of the decimal that exists here, okay? So if I'm doing this now, the equation would be like this. Multiply 1 here by 2, so it's going to be 2, 3. I'm going to multiply all the coefficients. All the coefficients, this coefficient, this coefficient, this coefficient, all of them I will multiply by 2, okay? So when you multiply by 2, this is going to be 2, and this one is going to be 7, and this one is going to be 4, and this one is going to be 6. So let's check now, okay? Let's check now the final answer. This is the final answer, okay? So how many carbon atoms do we have here? 4, right? And here we have 4 carbon atoms. Okay. How many hydrogen atoms? 12. 2 multiplies 6, 12. 6 multiplies 2, also on the other side are 12. How many oxygen atoms do we have here? 14 oxygen atoms. Okay. How many oxygen atoms do we have here? 4 multiplies 2 is 8, plus 6 multiplies 2 is, 1 is 6. 6 plus 8 is 14. So it is balanced. The phosphorus reacts with oxygen to produce diphosphorus pentoxide. So first of all, the oxygen here is even number and here is odd number, so I'm going to do the opposite. Like I'm going to put 5 here and 2 here. Why? To reach both for the first common factor, which is 10, and now the equation is balanced because 2 multiplies P2 is 4P, 4 phosphorus atoms, so it is balanced now. This, guys, another example of combination or synthesis reaction, okay? Sodium hydroxide reacts with sulfuric acid to produce sodium sulfate and water. So since the sodium is 2 here, on the other side is 1, I'm going to add a coefficient of 2. The hydrogen is 2 and here is 2, so we have 4 hydrogen atoms here and we have 2 only hydrogen atoms here. I'm going to multiply this by 2. Let's check for the oxygen. We have 2 oxygen atoms here and 2 oxygen atoms here. We have 1 sulfate group here, 1 sulfate group here. So now everybody is happy here of the atoms, and this, guys, is called a double displacement reaction. Why is double displacement reaction? Okay, double displacement reaction. Why it is double displacement? Because when the sodium takes the place of the hydrogen also takes the place of the sodium, makes water molecule. And also this another type of, this also called a neutralization reaction. So it's a double displacement reaction and neutralization reaction. The final one is the synthesis. This synthesis reaction. In this synthesis reaction, the magnesium reacts with nitrogen to form magnesium nitride. Okay, nitride, not nitrite. Mg3, and so I'm going to add 3 here, and it's balanced, right? Now it is balanced. Okay, guys, I hope that you like this video because it actually tells you how to balance a chemical equation, how to write down the chemical equation, how to assign the type of chemical, how to determine the type of chemical reaction, and also how to write down the chemical formulas in a correct way. It is a very, very, very important skill in chemistry. I hope that it helps you. I wish you all the luck, okay, and see you next video. Bye bye.